You're watching Alien
Math. Samuel Kim Production.
Alright, we're back with section 4.2 of Pre-Calculus 12. We're going to be talking about the unit circle today and how it relates to all that trigonometry we learned last day. Now, before I actually begin my definitions and everything else, I want you to take a look at this circle to the right here. And I want you to just remember, we're looking at radian measures, and we're looking at angles in standard position. So an angle that's right on the positive side of the x-axis is 0 radians. Okay, and as we move up, we get pi over 2 radians, and then pi radians, and then I think 3 pi over 2. Okay, over 2. Okay, now what I want to take a look at today then, let me just erase this so you can see it. Oh, can't see it. Is I want to talk about the unit circle. Okay, a unit circle is really just a circle with radius equal to, you guessed it, 1 unit. So before I begin everything, I want to just talk about the equation of a circle. And my question to you is, well, how would I go about finding the equation of a unit circle? Well, remember, an equation describes where all the different points are along a certain graph. So if I were to pick a point P, and let me call the point P over here, and the coordinates of P, of course, are x comma y, I'd like us to see if we can find a relationship relating x and y. Well, I gave you a hint. I said create a right triangle. So what I'm going to do is drop down a vertical, and then draw this line in connecting the center. And here's my right angle triangle. Now, before I go further, can someone tell me, I guess that someone's you listening at home, what is the actual hypotenuse equal to in this case? Once again, this is a unit circle. What's the radius of a unit circle? It's 1. Well, what's this distance that's horizontally here? Well, if that's the point x comma y, that distance must be x. And this vertical distance, you guessed it, it must be y. Well, this is a right triangle, so can you say Pythagoras? Say Pythagoras. I didn't hear you, not loud enough. Say it again. Okay. So, saying Pythagoras, hopefully you remember this. It's a squared or x squared plus b squared or y squared equals to c squared or 1 squared. Well, 1 squared is just 1, so x squared plus y squared equals to 1. So, ladies and gentlemen, there you have it. The equation of the unit circle. X squared plus y squared equals to 1. Those of you writing your SATs, you will need to know the equation of a circle. Well, how does this change then if I ask you to look at example number 1, determine the equation of a circle with center at the origin and the radius equals to 4? How would that change now? Well, all we're doing is we're extending the radius. Instead of it being 1, it'd be 4. So you think about my little diagram from above. Instead of this being 1, that now is equal to 4. Well, this is still x, this is still y, so how about x squared plus y squared equals to, you guessed it, 4 squared. And of course, that just simplifies to x squared plus y squared equals 16. Done. Now, as an extension, trying to review some stuff from chapter 1. How would the equation change if I actually move the center from the origin to this point 3 comma 2? So instead of it being there now, I'm going to say let's move the circle from the origins. Let's move the center from the origin to the point 3 comma 2. Okay, and of course I still have a circle with radius 4. Okay, so 4. Whee! Well, what did we do? When I move it from 0, 0 to 3, 2, you went right 3 units, and then you went up 2 units. So when I do right 3, remember I'm replacing x with x minus 3, and I go up 2, if I'm using the y's and just replacing the y's, it's actually y minus 2. So if I take that equation from above, I'll say instead of having x, it's x minus 3 all squared plus y minus 2 all squared, and the radius is still the same, it's 4, so we'll do 4 squared. It's 16. Done. Okay, that was just an extension. Okay, but how is this handy? Well, I'm going to ask you now, using the equation of the unit circle, to try to find missing coordinates for points on this unit circle. And that's example number 2 here. Okay, so if I said I know that the coordinate is negative 3 comma 4, or sorry, negative 3/4 for x, and I'm asking you to find the possible y coordinates on this unit circle, what could they be? So visually, if I were to ask you to draw a picture, here's my unit circle once again. Negative 3/4 is probably somewhere here. And I'm asking you, what is the possible y value? Well, it's probably up there or also down there. So what are the y values? Well, to do so, I'm going to use the equation of the circle to help us out. X squared plus y squared equals to 1. When I want to find out y, I think I should plug in what I know for x. So I know that x is equal to negative 3/4 all squared plus y squared equals to 1. Negative 3 over 4, so negative 3 squared is 9, 4 squared is 16. So 9/16 plus y squared equals to 1. And if I ask you to solve for y squared equals to 1 take away 9/16, or I'll say 16/16, right? I want to find the common denominator. Minus 9/16, I believe that's just 7/16. So y squared equals 7/16, and if I want to find out y, that's just the square root of 7/16 plus or minus, and I'll rewrite this as root 7 plus or minus over root 16. Why would I do that? Because root 16 is the same thing as, yes, the number 4. And those are your two y values right there. Okay. I'd like you to try the next one on your own. It's very similar to A. So I'll be quiet and you go ahead and do it. I'll draw the picture first of all, okay? So in this case, the y value is 12/13. You're looking for the two x values. How about there and probably there? Okay, one positive, one negative. Go ahead, please. Did you get plus or minus 5 over 13? I did. And I'm your teacher, so I'm right. There you go. Plus or minus 5/13. Okay. C is the same. It's a little bit more scary, so I'll do that with you together. It's x comma x. So what does that mean? Well, if I draw the unit circle, where is x comma x? Oh, by the way, it tells you in quadrant 3. So, x comma x means the x value and the y value are exactly the same. So they must appear on this 45-degree line. But this is in quadrant 3, so I think the point I'm looking for is right here. Well, let's go and plug it into the unit circle equation. So I got x squared plus x squared equals to 1. X squared plus x squared, that's 2x squareds. That equals to 1. We'll divide both sides by 2, so x squared equals to 1/2. And then now, how would you go about solving for x? Yes, take the square root on both sides. You get this. And if you don't like having the denominator with a radical or a root, we can rationalize it. Okay, so I'll just say rationalize denominator. We did this last year in grade 11. We just do this because math people don't like having the root in the denominator, but it doesn't really matter. But in any case, plus or minus root, oops, I should show you the steps, shouldn't I? To rationalize the denominator, all we do is we multiply both the top and the bottom by the denominator of root 2 over root 2. Okay, that's the idea of rationalizing. And then we get plus or minus root 2, and then root 2 times root 2 is root 4, or the number 2. Now be careful, this is not the correct answer because I asked you for quadrant 3, and notice in quadrant 3 the x value is negative. So the actual coordinate must be negative root 2 over 2, and of course negative root 2 over 2. Okay? So that's the coordinate for this point right there. Okay, pretty straightforward I hope so far. We're only 11 minutes in, so that's pretty cool. Alright, let's go ahead now and turn the page. Haha! Remember that you special triangle stuff also from grade 11? Do you remember having the 45, 90 triangle that looks like this? Right? And it's 1, 1, and then since it's 45 degrees, that's root 2. Remember that? And the 30, 60, 90 triangle, remember this one? Yeah, 30 on top, 60 in the bottom. This was 2, this was half of 2, and then the height was root 3. Okay, hope you remember that. If not, I showed it to you. Look back at your grade 11 notes. This time, though, I want to just make a slight modification. I want to ensure that all the hypotenuses are equal to 1, meaning the slant in here is 1, the slant here is 1. Because this is how I'm going to relate this to the unit circle. Okay? Now, this is 90. If this is 1 and that's 45, well, how does this compare with that? Notice that it's root 2 and 1. So to get to 1, I have to divide everything by root 2. So the new length here should be 1 over root 2 and 1 over root 2. Okay? By the way, if you don't like that, you can rationalize the denominator and write down root 2 over 2. Okay, that's just what I did on the previous page. It's up to you which one you use, the purple one or the red one. It doesn't make a difference, although I have a preference. You'll find out in a second. Okay? Knowing this, then, can you tell me what sine of 45 degrees is? Now, notice here I'm actually using pi over 4 as well because we're trying to get you to use this idea of radian measure. So sine of 45, sine, of course, is by definition opposite over hypotenuse. Remember SOHCAHTOA? Yeah, see all this stuff coming back now, right? So that'd be root 2 over 2 over 1. Well, I'm just going to leave that as root 2 over 2. Okay? Do you want me to write that down? Over 1? I guess I could. Okay? Cosine, that's adjacent. So root 2 over 2. Once again, over hypotenuse. That's just root 2 over 2. Tangent, well, that's just root 2 over 2 over root 2 over 2. Well, that's, oh yeah, 1. Tangent of 45 degrees is equal to 1. Okay. Let's go over here now to this other triangle. This is 30. This is 60. Notice how these relate now, the 1 and how that relates to the 2. So this time the factor is 2. So I guess I just have to divide everything by 2. So this becomes 1/2 instead of 1. And instead of root 3, it's root 3 over 2. Okay? Now, careful here. Sine of 30 degrees. Looking at 30 as your angle, sine is opposite, which is 1/2 over the hypotenuse, or just 1/2. Cosine, of course, is adjacent, so root 3 over 2 over 1, which is just root 3 over 2. Excuse me. And tangent is opposite over adjacent, so 1/2 over root 3 over 2, or 1 over root 3. Okay? So those of you who like to rationalize this, that's just root 3 over 3. It's your choice. Okay? Sine 60 means you look at the 60-degree angle and go from there. So I'll write this as 60. Sine 60, of course, is root 3 over 2 over 1. So that's root 3 over 2. Cosine 60, that's adjacent, so adjacent's 1/2, so 1/2 over 1, that's just 1/2. And tangent 60, well, that's root 3 over 2 divided by 1 over 2, that's just root 3. Okay? Now, I didn't tell you what the radian measure was, but as a quick review, does anyone remember? It's 30 degrees. Let's convert that to radians. I'll do it up here. 30 degrees. Remember, we multiplied by pi over 180 to convert. That's just pi over 6. So just make a note, that's pi over 6, okay, in radians. How about 60 degrees? Well, same idea. That's just pi over 3. So just make a note, pi over 3, pi over 3, pi over 3. Okay? You're thinking, Mr. Lee, why do we do all this? What's the point? Well, in example number 3, you'll get the point. I want you to fill in this whole diagram of the unit circle. We're looking also at the special angles, okay? So it says, on a diagram of the unit circle, show all the integral multiples of pi over 6 in the interval between 0 and 2 pi. That's one full cycle. Then I want you to label the coordinates for each point p of theta. So given each angle theta, I want you to go ahead and label the coordinates on this unit circle. And then describe any patterns you see in the coordinates of these points. Okay? Then we'll do the same thing for pi over 4, and we'll see what happens. Okay? Now, before we do this, let me just ask you to fill in the degree measures. Okay, let's do that first. Okay? 0, of course, is right here on the positive side of the x-axis. Okay? I'm just going to go up to here because I know this is going to be 90 degrees. Okay? So 90 degrees. And if I keep going around to over here, this will be 180 degrees. And then going down will be 270 degrees. And then coming back around, this would be 360 degrees. Okay? In terms of radian measures, do you guys remember that? I'll do it in red. So radian, of course, is 0. 90 is the same thing as pi over 2. 180, I believe, is just pi. Then 270 is 3 pi over 2. And then back over here, that must be 2 pi. Okay, I hope you're very familiar with these things. Okay, let's look at the coordinates of these four angles as well. This is the unit circle. So the coordinate here would be at 0 or 2 pi. That'd be 1, 0, right? The x value is 1. The y value is 0. Going up to 90 degrees, we have, yes, the x value is 0 because it's on the y-axis. And then the y value is 1. Remember, once again, this is a unit circle, so the radius equals to 1. Continuing over here, this is now negative 1, 0, because I went negative 1 to the left, right? And of course, the y value is 0. And down here, 0, negative 1. Okay? All right, now let's start doing the multiples of pi over 6. Shall we? Let's go ahead. So let's label the actual angles first. Okay, pi over 6, by the way, is 30 degrees. So this here would be 30 degrees. Another multiple of pi over 6 would be then 60. We've already got 90, so that's great. Let's move on. 90 plus 30 is 120. 120 plus 30 is 150. 30 is 180, and we'll keep going on. 210, 240, that's 270. 270 plus 30 is 300, and 330, and 360. Okay, now let's do the same thing in radians. So remember, 30 degrees is pi over 6. So I'm going to add another pi over 6. Pi over 6 plus pi over 6 is 2 pi over 6, or pi over 3. And then I add another one, that's pi over 2. Let's go further. So what's 120 degrees? By the way, if you can't keep adding pi's, then you can always convert 120 times pi over 180. Yeah, that's 2 pi over 3. Okay. And then 150 if you want to do it like that. Pi over 180. That's the same thing as 5 pi over 6. Okay. Try to do the other ones, converting them yourself. I'll be quiet because I know what they are. So you go ahead and try to convert them, and I'll write them down. Stop the video and try it first, okay? Okay, so coming back, I hope you got my answers, and if you did, bravo. If you didn't, fix them up, please. I'm going to now ask you to now do the hardest part of all this. That's finding the actual coordinates at every single one of these multiples of pi over 6. Okay? We're going to use the idea of the special triangles from above to help us out. Taking a look at the first one at pi over 6, okay? You don't need to draw this. So I'm going to try to highlight this to show you the triangle, okay? Whoop, 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 okay? You don't need to do this in your notes if you don't want to. If you do, then go ahead. This here, this angle is 30 degrees. So I'm going to actually ask you to use the special triangle with 30 degrees. That'll be the one on top. I'm going to take it and then probably like rotate it, I guess, counterclockwise, okay? And when you do that, can you tell me what the measures of these three sides are? Yes, I know the hypotenuse is always 1. I'm going to put that in purple. The bottom one here was probably, what, root 3 over 2? And then the vertical piece there is half. So remember how we looked at the coordinates, okay, of the actual point on the circle? Well, the coordinates represent the x and the y. In this case, the x value seems to be root 3 over 2, right? And what's the y value for this particular angle theta? It's 1/2. So there you go. You've got the coordinates of that point. Okay? Let me erase. Okay. All right. Let's now go and try 60 degrees. So once again, I'm going to highlight. You don't need to if you don't want to. Going to create here a nice right angle triangle. And then once again, this angle down here, the one by the center, is 60 degrees. So I'm going to actually ask you to find the side lengths again. This is 1. In this case now this is 1/2. And this is root 3 over 2. So what are the coordinates at 60 degrees? You got it. 1/2 for x, root 3 over 2 for y. Good. Okay, I'll do a few more with you, and then I'm going to let you try the rest on your own, okay? The next one is this one, 2 pi over 3. So I'm going to draw my right angle triangle again. Beautiful. Now, what's this? Oops. What happened? Now, what's this angle here that I highlighted in yellow? What is its measure? If you said 60 degrees, you're correct. That's what they call the reference angle. So once again, it's the 60-degree triangle. So this is 1. This is root 3 over 2. And this horizontal one is? And if you said 1/2, you are partially correct. Notice that this triangle is now to the left of the origin. So my x values are, you guessed it, negative. So what we should have here is negative 1/2. And then the y value is root 3 over 2. Good. Okay. I'm going to do one more with you, and then I'm going to ask you to try the rest of these multiples of pi over 6. Here's the last one I'm doing with you. Oh, what keeps happening? Why does it disappear? Okay, what's that reference angle there? If you said 30 degrees, that's correct. Of course, the longest side is 1. This must be 1/2. And then the horizontal side is not root 3 over 2, but negative root 3 over 2. So my x value is negative root 3 over 2. The y value is 1/2. Got it? Okay. I'm going to ask you to do the same thing for all the other ones. That's 210 degrees, 240 degrees, 300, and 330. Okay? You go ahead and do that. I will ask you to stop the video and ask you to start it after you're done so you can check your answers with mine. Okay? Oops. That was not smart, Mr. Lee. You just erased the correct answer. Okay, go ahead. By the way, after you've already done this, did you actually notice a pattern to all these things? I said see if you notice patterns. If you do, life is pretty easy. If you don't, oh well. Okay. Those are the answers for all multiples of pi over 6. We still have some blanks, so guess what? Let's do the multiples of pi over 4. Okay. Same idea. Pi over 4. I guess that's here. Pi over 4. By the way, what is pi over 4 equivalent to? Yes, 45 degrees. Then we've got 90. Let's do 135. And the equivalency of 135, I believe, is 3 pi over 4. Then we have 180. We'll add to that another 45. That's 225. That will become 5 pi over 4. And then 225 plus 45 is 270. Add 270 to 45, that's 315. Oops. Gotta keep this color coded. And I believe the radian measure is 7 pi over 4. Okay. This time, just for kicks, I'm going to go backwards. Okay. I will do this one first. 315. So notice I'm drawing a triangle, and this angle here must be, the reference angle, must be 45 degrees. So I'm looking at the 45, 45, 90 triangle. And I know that the sides are root 2 over 2, root 2 over 2, and this is 1. Be careful, this is below the x-axis, so my vertical value should be negative. So therefore, what's the coordinates here? Well, how about root 2 over 2 with negative root 2 over 2? Okay? Can you now go ahead and try the rest? It's the same thing as what we've done before. So find out all the coordinates of the rest of the multiples of pi over 4. Stop the tape now. Come back when you're done. Probably most of you went back up to do the 45 first. So the answer here is root 2 over 2, root 2 over 2. Doing the 135, that's negative root 2 over 2, because the x value is now negative. The y value stays the same. See patterns? The one in the third quadrant, I think that'll be negative root 2 over 2, and both x and y are negatives, because in the third quadrant. Well, ladies and gentlemen, congratulations. You have actually drawn the diagram of the unit circle, labeled these special angles, and figured out the coordinates of each of these special angles. Well done.